So whenever you see a negative inside there, it's always going to produce an I. Same with this one. It's 10I, and then you're multiplying them together. 15 times 10 is 150. I times I is I squared. I squared is -1. So this is 150 times -1 or -1, 150. Is that okay?
Yes.
All right. So that takes care of the first two. So 3 is slightly, I can't read the top numbers. Let me see if I can look them on my phone here. Maybe they're clear on the phone. Maybe. All right. So number 3, is it, what's on the top there?
It's 1 over x minus 3 plus 1 over x plus 3. Okay, yeah.
Yeah, I got it. I think that looks right. Um, all right. So it says to solve for X, show all steps. Now, you're supposed to actually first determine the excluded values. Did you guys talk about that at all? Maybe extraneous.
These ones I'm not as familiar with.
Okay, so the idea is that in math, you're not allowed to divide by 0. Division by 0 is very bad. It's punishable by, the worst uh, a thing ever. I don't know. It's very bad. So your issue here is like you could just solve this blindly and you could get an answer, but you also need to make sure that your answer is okay because you're not allowed to divide by 0. So when the bottom is 0, that's a problem. So when x is 3 or when x is -3, that's a problem because 3 minus 3 is 0, -3 plus 3 is 0. That's bad. Does that sound familiar to you or no?
Yeah, kind
Okay.
of.
Now, in terms of solving this, you have to make a common denominator. And when there's these things involved, it's more challenging than with numbers. So over here on the right, you're supposed to remember how to factor this. Like they expect you to be comfortable factoring this. X minus 3, x plus 3 have a difference of squares. Is that familiar to you?
Yeah.
Okay. So like the one on the left here has an x minus 3. The one here in the middle has an x plus 3. There's an x plus 3. But like the one on the left is missing an x plus 3. The one in the middle here is missing an x minus 3. So what do? Well, you combine them. You multiply the top and the bottom to get what you want here. So in this case, we're going to take x plus 3, and multiply the top and bottom. Then in the middle here, we're going to do the same thing with x minus 3, top and bottom. Okay. And then over here on the right, you already have it, x minus 3, x plus 3. So the goal is to make the bottoms all the same. And hopefully you agree that the bottoms are all the same.
Yes.
Okay. So the tops, you kind of just focus on the tops now. So because all the bottoms are the same, you actually can just look at the top. So you have x plus 3 times 1 plus 1 times x minus 3 equals 10. That's just the top. You ignore the bottom. We could get into why, or we could just do it. So this becomes x plus 3 plus x minus 3 equals 10. And then you solve this equation. This becomes 2x equals 10. Divide by 2, divide by 2. So x equals 5. And then you look to see if this is, look to see if it's excluded. And it's not. So the general flow of these problems is to determine, what your restrictions are, like what it can't be. and then you solve it and hopefully that answer is okay. Any questions, thoughts on that before we proceed?
No.
All right, so for number 4, I'll probably need some help here. All right, so is the number on this top left a 2?
Yes.
All right, what's the middle number?
A 5 and
And
then
then
a
I was
1.
okay.
And then the 1 under the 2 is supposed to be a 2 as well.
This right here is a 2.
Yes.
Yes, that makes sense. Okay, great. So it's kind of like when you're looking for your common denominator, you're like, it's sort of like, well, what are they missing? Like, what does one have that the other doesn't? That's what you're looking for. Like, okay, this has an x and an x minus 2. Well, this one in the middle here is missing an x minus 2. This one on the right is missing that x. Does that make sense? Like
Yeah.
you kind of decide what is it missing, what is it not missing. So you proceed here by multiplying by top and bottom by what you're missing. And so in this middle part here, you're missing an x minus 2, x minus 2. On the right here, you're missing an x and an x. And now all the bottoms are the same. Is that okay?
Yes.
All right. All right, now since all the bottoms are the same, you can just focus on the top. 2, the 5, yeah, anything on the top, basically. And keep in mind, like you don't have to multiply everything, just the ones that are missing stuff. So 5 parentheses x minus 2 equals 1 times x. So just the top again. All right. And then we solve. So this is 2 plus 5x minus 10 equals x. So we got 5x minus 8 equals x. Subtract x, add 8, add 8. 4x equals 8, and x equals 2. Okay. But what did I say that we're supposed to do from the beginning, or once you get your answer, you're supposed to look to see if it's excluded. And so here's the problem. When you put 2 back in the original, what's the problem here and here?
It equals 0 and it
Yeah,
can't.
and thou shall not divide by 0. All right. Straight to, detention or something. So it's bad, right? It's
Yeah.
excluded, which means that there is no solution. You tend to get something like this on a test or a quiz. Any thoughts on that?
No.
All right. On to 5.
Yes.
Right. All right. 5 is y equals minus 10x squared plus 4x minus 14. Okay, and it says to determine the x-intercept. So x-intercepts are where it crosses the x-axis. That's where y equals 0. These are sometimes called solutions. There's a lot of and then they're sometimes referred to as factors. There's a lot of things going on here. So you're setting this equation equal to 0. Okay. Or you're just looking at the equation without anything. You're just like, oh, I got to factor this. And the very first type of factoring that you're always supposed to look for, because it really helps, is what's called the graded common factor, which can be a number or a variable, or it can be both. So in this case, we're going to factor out a -2 from everything. Was it clear how I got the numbers inside parentheses?
Yes. Why
Okay.
did it switch to a -2x?
It changed the sign when you factor out a negative from each of them. So you're essentially
Oh,
dividing each of them by -2.
okay, I see.
All right. Okay, now there's a whole list of factoring here, like one is or two is maybe like difference of squares, and three is perfect square trinomials, and four is one thing, it's something else, and then five is what I call a not equal to one. It's when this leading coefficient here, five, is not one. And so the way to work these problems is you have to multiply the first number and the last number, 5 times 7, which is 35. And you're looking for two numbers that multiply to 35, but add to -2, which is impossible. So what did your teacher have in mind here? There is absolutely a mistake here. Let me just double check with something else before I say that for sure. Yeah, so there are no factors. Yeah. Maybe she meant plus 14. Yeah, she did. Yeah. Okay. I think your instructor meant plus 14 here,
Okay.
because the original one does not work. So you want us to do it with plus 14?
Um. Yeah, I don't care. Do we have to go back or just switch our signs?
It'll just, it's a signing. That sign changes, and then this becomes -7. And it will, if you could pretend like I didn't say anything for the last, 90 seconds, we're now finding two numbers that multiply to -35, but add to -2. That is 5 and -7. And the reason you do that, that's sometimes called the diamond approach. You're splitting apart this -2x into 5x minus 7x. And then you're factoring out the greatest common factor between these two terms. So you're splitting apart the -2x, and then you're factoring here again. So you factor out a 5x, which is x plus 1. And then what you do, and this is a little bit odd, is you immediately rewrite what's in parentheses here off to the right, and you're trying to figure out what goes in its missing position such that when you multiply in, you get back to the previous line. And I'll give you the answer just in case you've not seen this in a while. Imagine multiplying it by -7, you get -7x. -7 times 1 is -7. And then you have to factor again because these both have an x plus 1 in them. So you factor that out, x plus 1, and then 5x minus 7. The 5x comes from there, the -7 comes from there, and then you still should bring down this -2. And then this equals 0. All right. Is that sort of okay? We'll get a chance to, I think, another.
Okay.
So now you set each of these equal to 0. X plus 1 equal to 0, 5x minus 7 equal to 0, and x is -1, or x is 7 over 5, which is 1.4. Any questions, thoughts on that?
No.
Okay. So we can move on to 6 if you're ready. So again, kind of the same deal here. You're setting this equal to 0, or just, to factor it. First thing you look for is the greatest common factor, which in this case, there is a greatest common factor of 3. You can divide everything by 3. And you really want to look for that because it makes solving the problem so much easier. Otherwise, you're multiplying 24 times 9, which is pretty large. And I don't know if you're allowed to use a calculator, but it could get to where you can't do the problem because the numbers are so large. So whenever this leading number is not a 1, you take this 8 and you multiply it by the 3. 8 times the 3, 24. You're looking for two numbers that multiply to 24 but add to negative 10. So it's always multiply to the last, or in this case, the product, and adds to the middle. So 4 and 6 work, but we want negative, so -4 and -6, like that. Is that part something you've seen, or
Yes.
doesn't? Okay. So you're splitting apart this minus 10x, and there's always this question of like, well, which one comes first, -4x or -6x? And it's always like, well, which pairs better with the 8x squared? Which pairs better? And -4x, you will see, will pair slightly better with that. But all we've really done is just rewrite this line above it. We're not actually like doing anything really sophisticated. We're just splitting this apart. But it just so happens that this has a GCF. Again, in this case, it's 4x. And then whatever is in parentheses here, if you've done it correctly, you'll immediately write over here to the right. But you've got to figure out what goes in the middle. What goes in the middle such that when you multiply in, you get back to the previous line. What do you say? What goes there in between them?
3.
So
-3.
3 gets you to the 6, but negative gets you -6x. Good. And then it's kind of like double factoring because these both have a 2x minus 1 in them. And then you bring the 4x and the other thing down, and then you bring this 3 down, and then you set it equal to 0. So you set the x terms equal to 0. X equals 1/2, x equals 3/4, and there you have it. Any questions on that?
No.
Okay. All right, so for number 7, because you're asked to factor, you have to factor. If you didn't have to factor, you could use a different method to find this, which is just straight solving, correct method. This is called difference of cubes. So difference of cubes is when you have something cubed minus something cubed, it always becomes this. This whatever it is that you're cubing minus the other thing times a squared plus ab plus b squared. And so the setup here is like you have to figure out like what is your a and what is your b. Basically, it's like what are you cubing to get back to this previous line, and what are you cubing to get back to this previous line? Like what do you cube to get back to 8? Think about it.
2.
2, and then to get to x cubed is x. How about to get back to 1? What do you cube to get
1.
1? So your a is really 2x, and your b is really 1. So now you just put those into the formula. Instead of a, you write 2x. Instead of b, you write 1. Instead of a, you write 2x, but it's squared. Plus 2x times 1 plus 1 squared. And then you simplify as needed. So what I mean by that is, what you can simplify, you can, like 4x squared, 2x plus 1. This part on the right is never, ever, ever factorable. So you're done. You're done with that. But this one on the left, like you can solve. but you're done with this. You will never do anything more with that. But this one on the left, you set equal to 0, and you again get 1/2. All right, let me see what's next here. Okay, so for number 8, looks like it's a graphing problem.
Yes.
So I don't know, do you want us to do this, or do you want to do them on your own, or what do you?
Yeah, those two I can probably do with her or do on my own and then have her check.
It's up to you. It's up to you. I'm not trying to get out of doing. I'm just
I
trying
just
to.
won't have a graph or anything.
Okay. Well, so what I was always going to suggest is Desmos. Like, for number 8 here is just that's what I was asking if you are comfortable, because this, what you're going to find is that it's kind of intuitive how it works here. Um, so do you want to try that now or not?
Yeah.
Okay. Why don't you see if you can graph the first one? I will do the same here. All right, so if you graph this, you should see something like this. Maybe yours is a different color, something like this. Does that look similar to what you have on your screen? Okay. Okay, now you might wonder, like, okay, 12, I get that because the inside part is equal to 0 at 12, but what about the outside part? That's where it comes from, the domain. So the domain, you have to set the part under the root greater than or equal to 0. So you set x minus 12 greater than or equal to 0. So now you solve for x, adding 12 to both sides. So x has to be greater than or equal to 12. This is your domain. This means it's only good when x is greater than or equal to 12. And you guys are using interval or set notation in your class?
Um, yeah, a little bit. I've heard that. I just
Okay, so this is where you got almost, you really probably want to ask your instructor which one you're using. Are you using interval or set notation? Do you have the answers to this?
I don't.
Okay, that would also answer this question as well. So I'll kind of leave that to you to think about. Um, the next one is really similar. Well, no, I take that back. This one is, why don't you try graphing this one as well? Let me know when you've got a graph.
I've got it.
All right, so what I've got here, something that looks like this.
Yes.
And so the graph tells you the domain as well. Like, you can set the part under the root. greater than or equal to 0, but you can also just look at the graph and be like, well, what's the leftmost x value? And then how far to the right does this go? And even though it goes down, it's also going to the right forever. Even though it might look like it's going more down, it's still going to the right forever. So your domain here, divide by 2, divide by 2. So x has to be greater than or equal to negative 11 over 2. X has to be greater than or equal to negative 5.5, like that. Is that okay?
Yes.
All right. Um, okay, so number 10. So the I guess I can't fix those anymore. So number A, 10A here, it says x squared minus 16x plus n. I know you have a question mark, but it says find the value of n so that the expression is a perfect square trinomial. Okay, so to find n, there is a formula here. N is, you take this middle number, which is b. You can think of it as ax squared plus bx plus c. You take this middle number b, which is minus 16, and you do the following. You first divide by 2, and then the second thing you do is you square it. So you divide by 2, and then you square it. Can you tell me what that is?
Then 64.
It is 64, yes. So your value of n in this problem is 64. So for part B, it's exactly the same, I think. Is that x squared in part B, or is that
Yeah,
x cubed? Okay,
x squared.
okay. So again, to find this number here on the end, you have to take this middle number, your b, which is minus 12, you divide it by 2 and then square it.
So 36.
It's 36. All right, now for 10C, need a little help here. Is that 8x cubed or 8x squared?
8x squared.
8x squared minus 16x plus n. All right, so we're going to do something to start here. We're going to first factor out this 8. We'll talk about why in a moment. And we're going to just leave this empty. Or leave this empty. Okay. Now, we did 10B and 10A and 10B kind of are like what's inside parentheses. So we're going to take this B value of negative 2, and we're going to divide it by 2 and then square it. What does that become?
1.
1. So this is really a 1 here. So n though, or the previous line, this whole previous line, you get from multiplying in by 8. 8 times x squared is 8x squared. 8 times minus 2x is minus 16x. 8 times 1 is 8. There is a formula. I'm not sure why your teacher's doing it this way, but this is my preference for showing students. Seems to work out pretty well. All right, number 11. is completely unrelated to what we've been doing. Why are they giving you number 11? Is this a, oh, it looked like it's a trig review or something.
I am not sure.
Okay. It's sort of all over the place. This is like more like a problem you'd see in geometry. Okay, so the height of a light pole is, okay, so there's a light pole and it's 112 centimeters, and we need to convert centimeters to meters because the tower is in meters, and then there's this tower, and the idea is that the sun is up here and there's a shadow. Fast. All right. So to convert centimeters to meters, you may have done this in like a different course. There are 100 centimeters in 1 meter. So this is 1.12 meters is the height of the light pole, which is really short, by the way. Like light poles are like a lot higher. Yeah. I don't know. I can't make, is that right? Yeah. Okay. And then its shadow is 56 centimeters. Again, we got to convert that to meters. So the way you do that is you go back 2 decimal places. So it's 0.56 is the shadow. All right. And then the tower itself is 211 meters. Which again doesn't seem quite right. The Sears Tower is like over 1,000 feet. 211 meters is not even close to 1,000 feet, but I mean, I didn't make this problem. So this is there's really two triangles here. Okay. There's the little one. And then there's the big one. All right. And then if we call this distance here x, then the whole length here is x plus 0.56. Is that okay? How we've done that? Yes, no, maybe.
Yes.
All right. If you were back in geometry, you would recall that you set up a proportion for these types of problems. And you set up the proportion like, okay, in the large triangle, I know the base. The base in the large triangle is x plus 0.56. And you would ask yourself, well, what else do I know in the large triangle? Oh, I know the height. The height is 211. Now, what do you know in the small triangle?
That the
Do
base
you
is
know the,
0.56,
right? And the height is,
1.12.
all right. So now you've got a proportion that you can solve. But if you set it up here kind of as a table, you'll see how we constructed those values. So just rewriting it without all the extra stuff there. So do you remember here that you diagonally multiply? Diagonally multiply here.
Yeah.
So it's 1.12 times x plus 0.56 equals 211 times 0.56, like that. And then you multiply in here. So we definitely need a calculator. Please don't just take my answers because I do make mistakes, and definitely good to check me as well. But um, I will proceed here. So it's 1.12x plus 0.6272 equals 118.16. And so we solve this by subtracting this 0.6272 from both sides. So this is 117.5328. And then you divide both sides by 1.12. and you get 104.94. You have to be really careful though, because that is the value of x. That may not be the answer that they're looking for. Like if you go back to the original question, you will see that it doesn't want x, it wants the oh, sorry, I messed this up. So gosh, the shadow is 211. So it's actually much easier. All right, that's why I gotta check me here, because I sometimes will go off in the wrong direction here, and I did that here. So the shadow is actually 211, and all that does, it does make the proportion a lot easier to solve. So it's h over 1.12 equals 211 over 0.56. So to solve this, you multiply both sides by 1.12. And so h is just this over here on the right, which, like I said, it's considerably easier. 211 times 1.12 divided by 0.56 ends up being 422 meters. That actually sounds about right. That's over 1,000 feet, 1,200 feet ish for the height of the Sears Tower. So you can ignore all this. Although this, I mean, this is actually a good problem, but it's not what was intended here. So that leaves us with number 12. All right. This one looks like a calculator, like a pure go to your calculator and do this problem. So it says that the estimated number of adults that use the internet is given by this equation here. And we want to know when the internet use reached 94 million. So if we were to graph this, it would look something like this. And then here's 94 million. So it's going to hit that at some point. And so my question to you is, I guess, is like, do you know if you're allowed to just graph these, or do you have any?
She hasn't. My last year's teacher let us use Desmos, but she hasn't introduced us to anything with Desmos yet. So
Okay, so the way you would solve this by hand is you set the equation minus 0.25 t squared plus 16.9 t minus 50 equal to 94. And okay, maybe this can be done by hand. So we're going to subtract 94 from both sides. Minus 0.25 t squared plus 16.9 t minus 144. And then you factor out this. But let me just check. Yeah, so like I don't know where to tell you to go from here, because you can either use quadratic formula, you can graph it. Factoring out this doesn't make that nice. It doesn't make that okay. I guess you probably need to end up using quadratic formula. Have you guys been doing that?
yeah,
Okay, so let's go with that. So A equals minus 0.25, B equals 16.9, and C equals negative 144. So your quadratic formula here is minus B plus or minus the square root of B squared minus 4AC all over 2A. It's really important to treat those letters as if they're in parentheses, because when you substitute in here, you want to make sure that you don't miss a sign here. It mostly matters for when you have negatives, but 16.9 squared minus 4 times negative 0.25 times negative 144 all over 2 times negative 0.25, like that. And so you definitely need a calculator to be able to do this. Let me grab one here as well. Yeah, so it actually does work out nice, which I wouldn't have expected. So first one is 10, and then the other one is 57.6. When you do this. Now, you might be wondering, well, why do I get two answers, or what do I do with the two answers? That's where you go back to the problem, the graph, and you know that it hits it in two places. Um, Now, it says this thing is only good for t values between 5 and 24. So you say, oh, but uh, I got this t value of 57.6. Well, that's considered extraneous because it's outside the domain. So you would only accept that value there. So the fact that the answer is nice suggests that you could have factored it, but boy, that would have been tough. Been real tough.
The equation is what we've been using too.
Yeah. This one just happened to work out nicely. So good for us. Um, all right, so that takes care of everything on those two pages. Got, a little time left here if you want us to work on something else. What
I feel
else?
good about most of it. The only one is the um, shadow one. I like understand. It's also weird that it's not on our warm up. So I don't know
Yeah,
if
this is
that's what
this is
my
from geometry, similar triangles, basically.
but everything else I think I should just keep on practicing that I've got a good understanding
All right, well, we can stop here if that's okay with you.
of. Okay.
All right, go ahead and stop right here for today.